Welcome friends. In this lecture, we will discuss about Laplace transforms of derivatives. Now here, since we will be dealing with engineering mathematics 3, so generally the proof of any particular theorem or a property is beyond the scope of our syllabus. So we will be directly adopt the important results and will focus more on the problems which is based on those properties or theorems. So here, if Laplace transform of f of t equal to f of s, then we have the first result for the Laplace transform of derivatives as Laplace transform of f dash of t, which is the first derivative of f of t, and that is equal to s into L of f of t minus f of 0. So that means L of f of t, we know that is f of s. So this f of s should be multiplied with s and minus f of 0. So f of 0 represents the value of the function f of t at t equal to 0. Now again, if you have the second result with the second derivative as Laplace transform of f double dash of t, which is equal to s square L of f of t minus s into f of 0 minus f dash of 0. Now let's see the problems which are based on those results. So I have the first problem, that is if f of t equal to sin t divided by t, then find Laplace of f dash of t. Or sometimes it may also be asked like this, find Laplace of d by dt of sin t divided by t. So since f of t, so here f of t can be taken as sin t divided by t as per the given information. Then find the Laplace transform on both the sides, that is L of f of t equal to L of sin t divided by t, and accordingly we know that it is sin t divided by t. It's clearly a case of division by t. So first we'll have to find the Laplace transform of sin t, that is 1 divided by s square plus 1. This f of s or this Laplace transformation of sin t to be integrated between s to infinity with respect to s, and we have solved the problems in our earlier lectures. So that is tan inverse of s between s to infinity, which is further tan inverse of infinity minus tan inverse of s. And afterwards we know that tan inverse of infinity is pi by 2 minus tan inverse of s. So here we have tan inverse of infinity minus tan inverse of s, which is pi by 2 minus tan inverse of s, and in turn it is cot inverse of s. So what is the conclusion here? We found the Laplace transform of f of t, that is cot inverse of s, as equation number 1. But are we interested only in L of f of t? No. We need to find the derivative. So we have the result Laplace transform of f dash of t as s into L of f of t minus f of 0. So the right hand side, among these right hand side terms, we know that L of f of t, which is our cot inverse of s, that should be multiplied with s, but we don't know the value of f of 0. As I said, f of 0 represents the value of the function f of t at t equal to 0. So first we need to find the value of f of 0. So since f of t, as per the given function, f of t is sin t divided by t, and we know that f of 0 is obtained by substitution of t equal to 0. So we will substitute t equal to 0, then we will obtain f of 0 as a sin 0 divided by 0, and sin 0 has a value 0, 0 divided by 0, which is an indeterminate form because 0 divided by 0 cannot be evaluated further. So whenever we come across an indeterminate form, we know that by using L'Hopital rule, we can differentiate both numerator as well as denominator, and once again we substitute t as a 0. So here f of t as sin t divided by t. So by L'Hopital rule, it is f of t equal to differentiate sin of t, which is cos of t, derivative of t with respect to t, which is 1. So once again we substitute t equal to 0, which is cos of 0 divided by 1. And we know that for t equal to 0, f of 0 is cos of 0 divided by 1, and in turn the cos of 0 value is 1. So it is 1 divided by 1 as 1. Otherwise, if you don't want to apply this L'Hopital rule And since if you consider f of t as a sin t divided by t, by using the standard limit as limit t tends to 0, sin t divided by t, that is also 1. Okay, so I have mentioned here. Also, we can have limit sin t divided by t as t tends to 0, that is also equal to 1. So here we obtain the value of f of 0, which is 1. So that f of 0 as well as Laplace transform of f of t can be substituted in this particular equation, equation number 2. So we may substitute the value of L of f of t, that is cot inverse of s, and we have the value of f of 0, just now we obtained, that is 1. So from equation number 2, we obtain L of f dash of t, that is s cot inverse of s minus 1. So which is the final result. Now in the second problem, we have given quantity as Laplace of sine of root t, which is equal to root pi divided by 2s raised to 3 by 2 e to the power of minus 1 by 4s. So this information they have provided. Instead of L of f of t equal to f of s, we have L of sine of root t equal to this right hand side expression. And by using this, we have to prove that Laplace of cos of root t divided by root t as under root of pi by s e to the power of minus 1 by 4s. Okay, so here as I said, f of t is sine of root t. F of t equal to sine of root t. And we need to prove that LHS equal to RHS. In the LHS, we have a function with a cos of root t. And we know that the derivative of sine to be a cos. So we can think of finding f dash of t here directly. So what could be the f dash of t? That is f dash of t is, I have mentioned here, cos of root t divided by 2 root t. And then we can directly find its Laplace transform. So here L of f dash of t, which is equal to L of cos of root t divided by 2 root t. Then since f of t as we identified as sine of root t, what could be the value of f of 0? By putting t equal to 0, we obtain sine of 0, and that is 0. So here f of 0 is 0. Next, from the given information, we have Laplace of sine of root t as root pi divided by 2 s raised to 3 by 2 e to the power of minus 1 by 4s. So we can further rewrite them as 1 by 2. So this s raised to 3 by 2. So this particular term can be expressed as root of s dot s e to the power of minus 1 by 4s. Okay. And in the next step, we will have 1 divided by 2s under root of pi by s e to the power of minus 1 by 4s. Okay. So now we can apply the standard result as Laplace of f dash of t, that is the Laplace transform of f dash of t, which is equal to s L of f of t minus f of 0. So we have the value of L of f of t. Even we have found the value of f of 0. So we can substitute here. So Laplace of f dash of t, which is s L of f of t minus f of 0. So on the left hand side, we obtain Laplace of cos of root t divided by 2 root t, which is equal to s as usual, f of t as a root pi divided by 2s under root of s e to the power of minus 1 by 4s, value of f of 0 as 0. So we may cancel s here. And further, the simplified form of this step is 1 by 2 under root of pi by s e to the power of minus 1 by 4s. So finally, we may have 1 by 2 will get cancelled here for further simplification, and the final result is Laplace of cos of root t divided by root t, which is equal to under root of pi by s e to the power of minus 1 by 4s. So this is what about the final result. Okay. So for more problems, you may refer to the link provided in the description. And for any doubt or any type of query, please comment, and don't forget to subscribe, share and like the video. Thank you.